There we go. Okay, so we have a lot to talk about this week. This is going to be Chapter 2. Very quickly, there is one person here that I do have a graded rubric for assignment number 1. If you have not done assignment 1 by tomorrow at noon, because that's when I said the due date would be, you will start to lose points. Remember that assignments are graded differently than the tests. If you are late on an assignment, even by a minute, you will immediately lose 10 points for that week. If you are late again, you will lose another 10. The most points you can lose on any assignment, including the test, is 20 points due to lateness. So you can still get at most an 80. The first test is a little bit different, although it is almost over. It is due tomorrow at noon as well. However, if you turned it in today, your max grade that you could possibly get is an 81.5, because you were losing 1.5 points roughly every day up until tomorrow, which will be the cutoff day for how many points you can lose, which is 20. That being said, this week there will be another assignment that is due next Saturday at noon. And just keep that in mind. Now that we are changing days of classes, the due dates will change so that it is Saturday at noon, not Sunday at noon, that the assignments will be due.
Now, I know that you are changing the days. Are you possibly changing this as well? Because I know group chat there's been talk about.
As of this moment, what I would like to do is I would like to go back to the school. I know that apparently they're going to be doing some painting in the metal shop or something. I don't know what they're going to be painting. Whether they're doing a project in there or if they're actually going to be like painting the walls in the metal shop, which seems ridiculous to me. But that being said, my end goal is to get back into the school now that we're doing this on Saturdays. But we'll see how that goes. I'm not quite sure where that's going to put us just yet. But as of this moment, I'm hoping to get back to the school. Mr. Klein is going to be talking to somebody over at the school in order to get us back over there. But that being said, this is just the short introductory piece. I won't stop the video this time like normal. I'm just going to jump right in. This week, we're talking about 4 things: console input, scanner, variable types, and arithmetic and string concatenation. 2 of those things that I just said are actually one and the same thing, but that being said, let's talk a little bit about variable types first. Now, as with regular mathematical algebra, programming has variables. The specific difference being is that variables don't just store numbers in Java. They can store strings of characters, true and false values, and other things. Variables in Java are a lot more broad than variables in math. But to that same sense, they're also more specific as to what you can store in each variable. In math, if you have, let's say, the variable x, then you can store an integer, you can store a fraction, you can store a decimal number. In Java, you have to be a little bit more specific as to what you want to store there. So as we saw from last week, this is our generic template for how everything is going to look when we do programs in this class, at least for the time being. And what I want to go over first is 3 different types of variables that we'll be using quite a bit as we program in Java as we do robot programming. These are known as primitive types. These are types in Java that aren't objects. Now, I know we haven't talked about objects much, but just know that primitive types are the lowest you can go in terms of variable types in Java. They are the core of what makes up Java. Now, the first variable type that we're going to talk about is int. Int stands for integer. Basically, the only thing that you can store in an int is a whole number that is plus or minus 2.14 billion in terms of value. Okay? So, when you want to create, I'm talking over the dog now. When you want to create a new variable, basically what you have to do is you have to declare its type. So we'll say int. And then you have to give it a name. Sort of like a method name, like what we saw when we talked about what main was. So let's just call this some value. We then have to set some value equal to something. So we set it equal to, let's say, 6172. Okay? And then, of course, we have to end our line with a semicolon. So this is the general format of how you will see variables created in Java. It gets a little bit different when we try to create objects, but we'll talk about that as we get closer to working with objects. Yes, Hunter?
Grading this. On the last class that we did, the Hello New World where we wrote it and then we turned it into actual writing.
Mm-hmm.
Do you have, in this, do you have to do something similar to that, like putting parentheses around what you're doing, or like after int?
So we're gonna go over strings here in a few minutes, but I think that's what you're referencing.
Well, right now, all of that is just stored value.
So basically, if we wanted to do something with this, let's say that we wanted to print this value. We could say system.out.println and then just type some value. Java is smart enough to look and say, okay, what is stored inside some value? That is what I want to work with. So if we go to my main window here, and I click compile and run the program, we'll see 6172 pop up in the terminal window. Same sort of deal as last week. It's just rather than directly putting what we want to have printed into system.out.println, we store it in a variable, and then we print it based on what we retrieve from the variable.
So this basically shortens, instead of having to type out everything, you can just shorten it by putting in like some value.
Not so much shorten, but make it reusable. Okay? It doesn't really, if we wanted to print hello world 60 times on 60 different lines, that is Java putting in the effort to allocate the memory required to store hello world 60 different times, as opposed to having one variable that can be referenced that only has to store it once, and you just keep pulling the same value from that variable. Okay? So the next primitive type that we're going to talk about is double. Double can store numbers that are significantly larger than integers, and you can have decimals. So same sort of format as with int. You would say double, let's do pi, I guess. Double pi is equal to 3.14159265535.
Okay,
So this is the same sort of general format, and you can have numbers that are stored in a double that range from, and I can never remember this one. The max range of a double is plus or minus 1 times 10 to the 308th power. And that doesn't include the some, I think it's 26 decimal places after the decimal that you can have for resolution on the number. So double is there when you need to either really store a very large number, or if you need to store a very high resolution decimal number. Okay? Usually double would be used for something like very specific math, like with sensors or doing physics calculations or what have you, whereas integers might be used for counters, doing simple addition, subtraction, multiplication, what have you. Now, the last thing that I want to talk about for a primitive type is called Boolean. Now, this, more often than not, catches people a little off guard, because Boolean is not something that people really sort of think in. I should say Boolean logic is not it's not how we as people think, so it can sort of catch people off guard when they first learn how to do it. Basically, a Boolean value is either true or false. It relates back to the ones and zeros that we talked about when we talked about how computers themselves work. A 1 is true, a 0 is false. Computers use Boolean values to perform logic, to make decisions based on certain outcomes of certain equations. The formatting of a Boolean value in Java is the same as any other variable, with the exception of it either needs to be true or it needs to be false. Depending on what you're doing, this will change. And to just show you it in this format really doesn't show you what it would be used for, but it will become more important next week when we start talking about conditionals and how to make decisions in programming. But we can print any of these values as we did with the integer value. So let's say we want to print pi, and we want to print some Boolean. So if I go and I click on class 2 stuff and I run the program, and then we bring the terminal window back up, we'll see 6172 as we did before, and then pi, and then true. I didn't want to say all those numbers again. So this just sort of gives you a very general rundown of how there are 3 primitive types that we'll make a lot of use of in Java. And there are actually more primitive types that are available to you in Java: byte, short, char, float, and I believe that's all of them. Yeah, I think there's 7. I did teach you char the last time, but it's not... Char is one of those ones that I debated with myself whether or not I was going to teach it, and its usefulness is very minimal when it comes to robot programming at the very least. It does have its uses, but for the most part, in this situation, not so much. But that being said, before we get too lost here, I do want to talk about something called classified or class object types. Basically, any other type that you have in Java, with the exception of the primitive types, is an object. It has methods, it has instance variables, characteristics and behaviors that make up how it works and what it is. There is one object that we talk about very early on because it behaves very similarly to a primitive type in Java, and that is string. Strings are, in of themselves, an object. However, the way that they are written into the language, they actually behave more like a primitive type, at least when it comes to their creation. Now, string has a lot of useful methods and features in it in Java that we just don't have the time to cover all of in this class. But what I do want to show you guys is what it looks like to create a string, and then a couple of things that you can do with string that will become important as we move further down into the class. So, to create a string, you type the word string. It has to be capitalized. And I will say this, one thing that Java is very sticklery about is your capitalization and obviously your spelling. Spelling should go without saying, but if your capitalization is wrong, your program will not compile correctly. Period, end of story. Granted, your variable names have a lot more leniency with this, but you also have to be able to remember what they are. Variable names are a little bit easier to deal with. They can't start with a number. They can't start with a special character, and there are certain special characters that you can't use. They can't start with a capital letter. And it's usually best practice to follow this camel case sort of format, where the first word is lowercase, and then any subsequent word is capitalized. So some value, some would be lowercase, and then value would have an uppercase letter to start it. Does that make sense? It makes it a lot easier for someone who hasn't worked on your code to actually read it. So, that being said, string, and then let's give it a name. Let's just call it hello, and we'll set it equal to hello world. Okay? What? Because string is still not a true primitive type. No. BlueJ has a specific set of guidelines for certain reserved words in the language that will change the colors accordingly. Things that are relevant to how classes are constructed are normally done up in purple. Things that are relevant to either declaring types or primitive types, so like class, void, int, double, boolean, char, etc., those will be red. Okay? And then blue is conventionally used for block comments. Gray is conventionally used for single line comments. And there are a few other colors that we'll see later, but for the time being, they're not that important. With that being said, string hello equals hello world. We can now, if we want to, just use hello as our reference to hello world, and then copy and paste that line. Well, not 70,000, but we'll compile, and then we will.
Can you run it from in the programs, or do you have to?
I think they removed that. They did. They removed that from the UI. Oops, that's my Steam. So if we look back at the terminal window, we see that hello world got printed 5 times. So the 5 times that we had print line there referencing the variable hello. Okay? That makes sense?
Yeah.
All right.
So, one thing I actually want to ask is, what would
string hello in system.out.println,
Yeah.
Java will get confused. Because it will think that it will assume that you are trying to declare a variable inside a method parameter, which is not something that you should ever do. Right. So like if we put string here and then we go compile, errors found in class, and it will put red marks where the errors are, and if you hover over it, it will give you some sort of strange error that really won't make much sense, because Java is like, I don't really get it. But that being said, we have a few things to talk about that have to do with methods that are available to you when working with strings. Now to do this, I need to create another string. I am going to remove these extras here. We could say string dogs equals the mad dogs. Oops, the mad gods. It's a little bit different. Okay. So now we have two strings, okay, that we can work with. Now, like I said, unlike primitive type, strings have methods because they are objects. They have behaviors that you can enact on to make them do different things. There are 4 that we're going to talk about today. There are so many more. There's probably 40 or 50. But these are the ones that will be important for you guys to be able to complete the assignments that I give you for this class. The first one is equals. Now, normally with primitive types, there's a very specific way that you would check to see if 2 values are equal to each other. However, we're going to take a short pause. I just got a text message that doesn't regularly happen, and I need a moment. So we will come back to this. We will talk about the methods of strings here in a moment.
Contacts.
All right. So let's continue here. We are almost done with this piece of the day here. So I'd like to get it done and out of the way. Equals. Let's talk about equals. So equals is used to determine whether or not 2 strings are exactly the same. Okay? So if we do system.out.println and we say hello.equals, and then let's type in hello world. So basically the way that you reference a method in Java is you call on the variable name, you put a period after it, and then the method name, followed by parentheses with whatever parameters you want, whatever parameters are required to make that method work, if there are any. Okay? Very similar to how println works. In this case, we put something called a string literal, which is just a string in quotes that we don't assign to a variable. And that is the value that we want to test against in order to determine whether or not those 2 values are equal. Okay? Now I'm going to put one other thing here. I'm going to put another system.out.println. And we're going to say hello.equals. And then we're going to say dogs. Now, equals returns a true or false value. So, what do you expect the first line to return?
True.
What do you expect the second line to return? Say that again.
Yeah, but
the quotes. Remember that the quotes only define that this is a string. That doesn't make the quotes a part of the string. Remember, you'd have to escape use a backslash to make the quotes persist in the string. Okay? So, let's compile this. And then, that's right. So we see true and false. Well, we didn't type that out, but remember, this is happening in order, Hunter. So this happens first, this happens second. Okay? So that is the gist of how equals works. That would be used if you want to know if everything is the same capitalization, the same spacing, everything. That is equals. Okay? So now, the next method that I'm going to show you guys is equals ignore case. Okay? Can you get equals ignore case? Do you guys have a semblance of an idea of what that might do?
it's not case sensitive.
Right. So if we do system.out.println and we say hello.equals ignore case. Whoops. Hello world. And then we say system.out.println hello.equals_ignore case. And then hello world. Are they both
Yes.
the same?
Yes.
Will they both return the same thing?
I'm guessing no, since a lot of them is not the same capitalization.
It's ignore case.
But remember, it's equals ignore case.
Ignore capitalization.
Yeah.
Yes.
Oh my word.
So, if I compile, and I run, and I open the window because it won't open on its own, we see true, false, true, true.
Okay, that makes sense.
Okay? So, boy, this thing's getting hot.
But
So, equals ignore case, fairly similar, fairly simple. So now the next thing is length. It's pretty regular that you would need to figure out the length of a string, surprisingly enough. It's actually not that uncommon. So if we say hello.length, that will return an integer that is the number of characters in a string. Now my question to you two is, do characters include spaces and punctuation? Hunter?
to be honest, I might say
All right. Well, let's put the other one in here, and then we'll find out. So,
I feel like it's gonna be now.
Issue. Tackles.
never assume. 12 and 12. 5 and 6, so we have to include the space in order for it to be 12.
So basically, this is saying that they have the same amount of words.
The same amount of letters, the same amount of characters,
Amount of letters, including spaces.
including spaces and punctuation.
Oh, so they would count as an extra letter.
Yes, a character.
Okay.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And then the same thing down here. We have 3 for the, 3 for mad, 4 for gods, and then plus 2 spaces.
Oh, okay. Yeah, that makes sense.
Okay? So, now, there is one more thing that we have to talk about that's a little less simple. But you won't use it as often as the other 3. But it's still useful. It's called substring. Substring is used so that we can take one string and remove a piece of it. Okay? So, let's say that we wanted to remove a piece of the hello string. We would say hello.substring, and the parameters required for substring is actually 2 integers, where we want to start from and where we want to end. Okay? Well, no. Because what does a computer start counting from for a number?
0. Oh.
0.
Okay, so it's actually 6 and 11. Well,
If we wanted to pull world out of the string, then yes. Computers start counting from 0, which means that arrays start counting from 0. All a string is an array, a set of characters that is starting index from 0 to the length of the string minus 1.
So basically, it goes from 0 all the way to the maximum on the end of it, and you take away 1.
Right. So if we were to count out how the value of hello works, it would be h is equal to 0, e is equal to 1, l is equal to 2,
And so
l is equal to 3, whoops, l is equal to 3, and o is equal to 4, and so on. Okay?
now, when you're saying you want to start from one point to another, would you have to include that minus 1 on it?
So if you put in 0 to 12 for the substring, you'd get an error.
Why is that?
Because you've overrun the array. There isn't a... Technically, you'd be saying that there's a 13th character, which there isn't. Because remember, we start counting from 0, but there's 12 characters, which means the most that we can count up to is 11.
So basically, you got to do 11 so that you have 12 characters.
Correct.
Oh, that makes a lot more sense.
Okay. So, if we put in, let's say, 0 and 4, it should, if I counted correctly. Oh, error? Did I forget my semicolon? Oh, I forgot a parenthesis. Whoopsies. I got distracted. I got another text message.
stop texting and programming.
Actually, yes. So if we run this, then we should see at the end of our output, hell. Lovely. I miscounted somewhere.
So if you want to include that 0, you have to
So we would have to extend it to 5 in order to get to where we want to be here. Oops. But that being said, if there are no questions, we're going to stop this video, take a few moments, I'm going to answer my text message, and then we will move on to console input.
Okay.
Are we good?
actually, I do have one.
Okay.
So when you say you mess up on the count, you basically go from 0 to 5, but you don't include the space on the end.
Right. So in order for it to be inclusive, we would have to say 0, 1, 2, 3, 4, 5. So it won't include that 5th character there.
Okay. Yeah.
So wait, so that isn't the part in the...
So 0, 1, 2, 3, 4, but it doesn't include the 5th. It's not inclusive.
Even though you type it.
Right, so if I type 5, if I put 5 here, then it will not say hell anymore.
That's hella good.
So if I go like this, and then I go back to my window here, hello, okay? So the first number is inclusive. The last number is not. Okay? Sorry I didn't make that clear. I knew that fact and I had miscounted and was like, what the heck did I do? But that being said, we're going to stop for a moment. This will be one section of this chapter, and we'll move on to console input in a minute.